Hello, everyone, and happy Tuesday. I guess it's Tuesday now. It's a pleasure to be able to talk to everyone about math today. I see that we have 139 people who have already showed up, and what are we going to talk about? Well, I don't know either. The way that this live stream works is we always go and find out what kinds of questions people are interested in, and we'll talk about, we'll talk about interesting topics of math, which we hope are not going to be things that you have already seen in school. Actually, many of you have already had class today, probably from school, and my goal is not to just give you another math class. You already got that. My goal instead is to try to show you something that might not be as easy to find in a textbook, which is a way to maybe answer any kinds of questions that you might have, where the questions can range across mathematics and science and just about anything. Now, when I say just about anything, what I mean is you can ask just about anything. The kinds of questions that I will choose to answer will be the ones that I think that my answers will be understandable to people who are studying algebra or geometry. And I know that there are some people in this audience who have some very, very advanced questions. I apologize, I will not be able to answer your very advanced questions, only because I want to make sure that this stream is accessible to as many people as possible. Okay, well, welcome back for all of you who have been here before, and welcome if this is your first time. Let's go ahead and get started. What kind of questions do we have today? I see that there are some questions who are still wondering about this green shirt. Unfortunately, I'm not yet celebrating in the sense that I'm still working hard on a few things, so we won't pull out the green shirt quite yet. What else can we see here? Oh, interesting. Somebody asked, prove why time multiplied by speed equals distance. So that's interesting. I've been thinking about that recently too, as some of you know. So let's get a pen. Time multiplied by speed equals distance. Well, why not? I guess that's the question. Why not is a pretty bad answer to give you. The best way to think of it is you've got three things. You've got a time, and you have a speed, and you have a distance. Now, I know a lot of people remember this as time times speed equals distance, or distance equals rate times time. That's how a lot of people remember it. But the way that I would think about it is just, what are these anyway? You see, time is time. It's just measuring how long something has taken. Time might be in units of time, or like in hours. Maybe it's like 3 hours. And distance is another really basic concept. It's like how far something is. And to me, distance you'd measure in the concept of maybe miles if you live in the United States. Maybe it's something like 180 miles. So now, I just said that these two are somehow two very fundamental units. And indeed, you can actually make a lot of the units that you see in physics out of some very basic units. The most basic units are the units of mass, the units of length, and the units of time. And all kinds of other things you can make out of that. Like, if you want to know how much energy there is in something, you can actually describe energy in terms of kilograms, meters, and seconds, or basically mass, distance, and time. But when you think about that, you say, okay, what else can I do? Oh yeah, you're asking, why am I using the metric system? It's because you can see I flipped between two different things, Luke. When I was talking about these normal things you're used to, I said the way that I used the units that we're used to using in America for time and for distance. But once I started thinking about things like energy, I was like, well, I'm used to thinking about physics. And in physics, we measure energy in other units that have to do with, like in joules, which have to do with these kilograms, meters, and seconds, which are not here. But okay, so once I've got these two, what do you use to measure speed? Well, you see, so the whole point of speed is to tell you how fast you're going. And you can know how fast you're going if you're like, well, I went 180 miles in 3 hours, right? That's a speed. So what I'm trying to say is that, to me, it's not really that distance equals rate times time. Rather, it is that speed equals distance divided by time. I mean, that's actually maybe how I would think of it. I would just say that speed is equal to how far you go divided by how long it took for you to get there. And that also makes sense because if you look at the units would be something like 180 divided by 3, which is 60 miles per hour. So the way that I would prove that the distance equals rate times time is I would basically say, well, speed is the distance you went divided by the time you took. And so therefore, speed is distance over time. We'll multiply both sides by time, and you get time times speed equals distance. But whenever you're confused, just draw out an example. And once you draw out an example and you think about what miles per hour means, it works. Someone's quite funny. They said, I am time. Also earlier in another live stream, somebody had said, I am speed. Well, clearly, we just need someone to say, I am distance. Okay, let's see. What else can we do? More questions, more questions. I'm just scrolling on my little screen here so that I can see the most recent questions also appearing. It looks like some people have indeed said, I am distance. I am space. So we have all kinds of different things that you can use. Actually, space is 3 dimensions of distance. So it's almost like, I don't know, it's like distance in each of those 3 dimensions. Often we call them X, Y, and Z. And now somebody, Dayit, says they are space-time. Let's see, what else can we do? This is interesting. This is quite interesting. So somebody said, so Eric F. asked, Bob the unpredictable cat walks on a 1-mile racetrack at 1 mile per hour. Is it possible to calculate how long it will take him to do 1 lap? You guys like cats. You guys seem to like these unpredictable cats. So somehow there's a 1-mile racetrack. Let's pretend this is a racetrack, okay? This is 1 mile. And you're saying that there's the Bob. Bob is this unpredictable cat. I don't know how to draw a cat, okay? So let's pretend that this is a cat. Let's just write Bob. Oh, Bob cat. Maybe you guys are being funny. Yeah, so this is a Bob cat, or Bob the unpredictable cat, and is walking on this racetrack at 1 mile per hour. This is a pretty slow cat. 1 mile per hour. Bob the unpredictable cat is moving along this circular racetrack, or this looped racetrack at 1 mile per hour. How long will it take for Bob to finish one? It needs a tail. I understand, it needs a tail. Okay, great. So how long will Bob the unpredictable cat take in order to go all the way around? Well, if you look at this at the beginning, you'll be like, well, come on. It's 1 mile, and it's 1 mile per hour. So surely the answer is it should take 1 hour, right? That seems quite reasonable. Now, that is pretty slow indeed. But actually, if you know about cats, I'm pretty sure that Bob the unpredictable cat will not just walk along this all the way around in 1 hour. In fact, most cats, if you tell them just like go and walk a mile, the cat will basically decide not to walk a mile. And then what are you going to do? Right? Yes, but he is unpredictable. Thank you, Eric F. So now let me try to find a decent model for this. Right? I wonder if what I can do is I wonder if I can instead say that Bob the unpredictable cat, you know what he's going to do is he's going to kind of randomly move forward or backward. And he's going to randomly move forward or backward a whole bunch of times. To make life a little bit easier, let's do this. So 1 mile is, in our normal American units, is 5,280 feet. So let's write down 5,280 feet. Whoever invented this, I don't understand. Okay? But so it's 5,280 feet. And now let's assume that this cat, it's not that the cat's just going to move straight along the track at 1 mile an hour. Let's assume that, 1 mile per hour in terms of feet per second. Does anyone know how many feet per second that is? I'm a little curious. So anyone can help me? Let's try. I just want to know because I want to think about feet. I'm thinking that Bob the unpredictable cat is going to randomly move 1 foot to the right or 1 foot to the left. That's what we're going to do for Bob the unpredictable cat. Okay? So I would like to know what 1 mile per hour is in feet per second. So let's see. How would I do that? Let's just get an idea. So if I have 1 mile per hour, that's equal to 5,280 feet every 3,600 seconds. And I'm going to be lazy. I'm going to say, that's approximately 2. And indeed, actually, somebody has a more precise answer, 1.46667 feet per second. I'm just going to say, let's simplify the problem, 2 feet per second. Okay, so this is Bob the cat's speed. And I'm going to assume that every second, Bob is going to go forward or backward by 2 feet. Okay, let's make the life easier. So every single second, forward or backward by 2 feet. And I agree, it's more like 1.5, but I just want some approximations because I'm about to make more approximations also. So we're going to change up the problem. Bobcat is not going to go automatically forward. Bobcat is going to go forward or back by 2 feet forward or 2 feet backward every second. Uh-oh. So now this becomes an interesting question. Now, how long is it going to take for Bob the unpredictable cat to go 1 full lap? What do you guys think? Do you think Bob the unpredictable cat will ever make it 1 lap? I mean, Bob's basically just going like forward and backward and forward and backward and randomly going forward and backward. Do you think Bob is ever going to make it? Or will Bob just kind of go back and forth and never actually go wiggle, wiggle, wiggle all the way until Bob is able to get around? Well, this is a funny thing. Oh, you're saying now Bob is a fast cat. Yes, Grace, thank you very much. Bob got faster by just a little bit. But unfortunately, not only did Bob get faster, Bob lost all sense of direction. So at this point, this is like a back and forth and back and forth. Bob is just like wiggling back and forth. Will Bob ever make it? So some people are saying, maybe it won't happen, right? And actually, there's a word for this. This is called a random walk. A random walk is something where you kind of randomly go up or randomly go down every single moment, like every single second. What's the question, Andrew? The question says we've got Bob the unpredictable cat. Every second, Bob will go 2 feet forward or 2 feet backward. And the question is, will Bob ever make 1 full loop? Meaning like in Bob's random wiggling of going backward and forward, will Bob ever kind of like get all the way around 1 full loop? Bob the dizzy cat is maybe the more appropriate way to say this. Well, it turns out the answer is yes. It turns out the answer is yes because, yes, exactly. What if Bob went all the way backward? But you know what the probability of that is? If Bob goes all the way backward and goes backward 2 feet, 2 feet, 2 feet, 2 feet, 2 feet, approximately 2,500 times, what's the chance of flipping a coin? Because basically Bob's flipping a coin, right? And Bob's like, okay, I'll flip a coin. Oh, I'll go forward or I'll go back. What's the chance of flipping a coin? And 2,500 times in a row, you all get heads. I mean, if you got that, you probably have a coin that has both sides heads or something, right? It's very, very unlikely. But the deal here is that actually, if you really do flip enough times, eventually you do get some what we call a standard deviation. There was a question that people asked before in this daily live stream, like what's a standard deviation? And you see, if you flip a coin, which is what Bob is doing, if you flip a coin, if you flip a coin 10 times, you won't get exactly 5 heads. I mean, maybe people have noticed this. Let's write down something here. So suppose you flip a coin 5 times. No, not 5 times. 10 times. Then the number of heads, let's write a number sign. It's supposed to be 5. But as you know, it's not always 5, right? Like if you flip it, it's not always going to be 5. So if it's not always going to be 5, then what is it? Well, it's 5 plus or minus a bit. And some of you know that if you kind of flip a coin more times, like not 10 times anymore, let's flip a coin 10,000 times. That's a lot of times. Flip 10,000 times. The number of heads is supposed to be 5,000. But it'll never exactly be 5,000. It's like most likely it would be 5,000, but there will be some spread, and that's actually how you draw this kind of a graph. You'd say somehow, how many heads am I going to get? Well, if I flip 10,000 times, the number of heads I get looks sort of like this. Actually, it doesn't quite look like that. That looks more like a mountain. Maybe this is a little bit better. Okay, it looks like this, and the most common is at 5,000. However, it turns out that there's something called a standard deviation, which is like about how much is out this far. If I want to know what's the distance from I'm blocking the 5,000, from the 5,000 to around here, that's called the standard deviation. And what you'll learn in a statistics class is that has to do with the square root of the number of times you flip. So I'm going to call this n. If you flip n times and you flip a coin, it turns out, and this is more deep than I can talk about in this particular class, because this class that we're doing here, well, it's not a class, but this live stream we're doing here is designed for people of all different ages. So I want to make sure that what I'm saying is something which, you could use, but maybe we won't be able to explain exactly why it's true. But if I want to know about how much this gap is, And here when I drew these arrows, I didn't go all the way to the green. I sort of said about that much of this gap. Actually, is there anyone here who knows? I'm curious. Because if there's someone here who has taken a high school statistics class, if you flip a coin n times, and it's a fair coin with a half chance of being heads and a half chance of being tails, it's actually well known to people who are in high school that this standard deviation, which is this amount of gap, is about, well, not about, but it's about square root of, it's going to be n, and it's actually going to be n times 1/2 times 1/2. And there's a formula for this. That's not something that I really want to focus on. But I'm saying that this particular distance here is about square root of n times 1/2 times 1/2, which is, by the way, square root of n divided by 2. I think this is right, by the way. So if there's anyone here who actually is a statistician, please correct me if my square root of NPQ is wrong. In some sense, this is not actually the area that I usually work in. However, I know what I know about it is it's going to be something like square root of n-ish, and I think the constant is square root of n times half times half. I'm not going to, don't quote me on that necessarily. But it looks like Skylar does seem to believe that this might be right. So, okay. So somehow it's like this amount that I'm going to deviate by is about square root of n divided by 2. And why did I choose 10,000? Because at 10,000 I can take the square root of 10,000. So if I take the square root of 10,000, I get 100. And so what that's telling me is the number of heads would be around 5,000 plus or minus like 50. So I'll write like this, plus or minus 50. Now this plus or minus is not the same plus or minus that you see in the quadratic formula. I don't mean that the number of heads is either 5,000 minus 50 or 5,000 plus 50. I mean, it's kind of in that range. That's what statistics is useful for. Okay? Okay, so then why is this interesting? Well, this is interesting because, look, the number of heads is about average plus or minus something. And now think about what would happen if you were the cat. If you were the cat and you had flipped 10,000 times, what that means is where you would be, well, you'd get 5,000 plus something steps forward, and 5,000 minus something steps backward because there are 10,000 steps. Let me write that down a bit more clearly. This is very important. So what would the cat get? The cat, after taking 10,000 steps, the cat would get forward, how much? Well, 5,000 plus an unknown amount. I use the capital X because whenever you do statistics, you use capital letters to represent what we call random variables, where we don't exactly know what they're going to be, but they're going to vary. But if you have 5,000 plus X as your forward steps, how many backward steps are you going to have? Remember, we're taking 10,000 steps. So I saw somebody ask, what's the question? Sophie, the question is if you have a very confused and dizzy cat, and the cat is taking steps forward and backward, where at every second the cat flips a coin to decide whether to go forward or backward, the question ultimately is, how far away from the starting point does the cat get? And so the important thing here, yes, I already see, no name has answered. If the cat is taking 10,000 steps, and 5,000 plus X of them were forward, then 5,000 minus X of them are backward. Now let's combine these two. If you move 5,000 plus X steps forward is for you guys this way, and you also move 5,000 minus X steps backward, on the net, how far has Bob the cat moved from their starting point? This is interesting, right? So cat is moving how many steps? Well, 5,000 plus X this way, 5,000 minus X that way. So how many steps away from the starting point is the cat now? Well, it's 2x. Thank you. Thank you very much for answering this question. So what this means is that the cat is now forward 2x steps. Okay, so now this is interesting. You see, if I want to make this 2x bigger, looking at this distribution, there's a lot of distribution, there's a lot of chance that you are anywhere around here. In fact, it's very, very unlikely that you get exactly 5,000 heads when you flip a coin 10,000 times. But the way to think about, like if you're flipping the coin and taking this random walking forward and backward, what's the chance that you'll eventually move a certain amount of distance? This is not a precise answer I'm giving you, but it's a ballpark idea. The ballpark idea is, well, if you want to know when you might have deviated a distance, which might be, let's go back here. we want to know when we might have deviated a distance, which is about 2,500 steps, because we're doing 2 feet forward for a step. The question now is like, when could I have had, like, could I have gotten to a point where my net deviation from where I started, my net walk forward or backward from where I started, is like 2,500 steps? Could I do that? Well, you look at this and you say, well, how could I make this equal to around 2,500? How could I make this equal to about 2,500 steps? I could do that if only my x was around 1,250. So then we go all the way back here and we say, well, right now the x is only 50. If I want to know when my x would be 1,250, then what do I need? Let's go back and trace through all of this, right? Because if n was the number of coin flips, n was the number of decisions, then I'll know that how many the x, which is how much forward or backward, I mean how much extra there is away, how much deviation there is away from what we're supposed to have. Well, that x will be this thing, square root of n over 2. So if I want to know when will I maybe have Bob the cat go all the way around, I just need to know when would this number be around 1,250. Because if this number, this is the x, if the x is 1,250, then the 2x is 2,500. So now let's figure out, when is this equal to 1,250? Right? So the point here is what we're saying is that, you know, we have this cat which is making these random decisions, and the question is, how many random decisions does the cat have to make before their deviation away from perfect same number of forward and backward steps gets too big? Aha, the cat is very stupid. You're right, because we're going to get a huge number, because I take the 2 times the 1250, that's 2,500. So that means that the number of steps the cat has to take is approximately, in order to get this, square root of n has to be 2,500. So to get that, I need to have n to be the square of that, which is 625 for the 25 squared, and the 0000. So this cat needs to take 6,250,000 steps, roughly speaking, before the cat will randomly have gone all the way around, roughly speaking. Okay, how long will that take? Well, you told me it does this once every second, right? So it takes this many seconds. Let's convert this into hours, days, and years, okay? So I have 6250000 seconds. 6250000 seconds. If I want to convert to hours, let's divide by 3,600. 6250000 divided by 3,600 hours. How am I going to do this in an easier way? Well, let's just start canceling first. Got some zeros. No more zeros over there. If I see the 36, honestly, to me, I look at the top, 6250, and I think that 36 times 2 is approximately 72. Close enough. So I would call this, if 36 times 2 is 72, here I have 62500. I would call this approximately 200. Wait, that's it? That's pretty fast. This doesn't even seem to make sense to me. But anyway, so if I'm doing this, I'm like the 36 divides up into there, and the 36 times 2 would be 72, but I don't have 72, I have something close to 72,000. Oh, 1,000. So I need to add actually 3 zeros. And it's not equal to this, it's approximately equal to this. Am I right there? I think I'm right there. So this is 2,000 hours. Not 2,000 seconds, because we had the number of seconds before we converted it into hours. So yeah, thank you very much. Somebody has 1736.17 seconds, close enough. So if it's 2,000 hours, let's convert it into days. About 24 hours are in a day, so let's just divide by 24. And again, you know, I'm being off. I'm rounding quite a lot. But dividing by 24, it's going to be about 100 days. And you know, if I was going to say, since I did all this rounding, I wouldn't be surprised if the answer is something on the more like 50 days. Maybe I should have been more careful. But yeah, to me it feels like it might be like 50 days, 60 days, 70 days-ish. Somebody says 80 days. Close enough. The cat basically needs to be walking non-stop back and forth for like around 100 days. Something tells me that the cat will not keep doing that. So in that case, I guess maybe the answer to your question is never. given that the cat is just moving back and forth. And you can see I'm just trying to get a ballpark, because I was like, is this going to be, for example, 100 years? If it's 100 years, I'll tell you for sure it's never, because no cat can live 100 years anyway. But so the answer to your question, I hope, is more interesting than you were expecting. What we just did is we actually just talked about a random walk. The random walk is something which at the beginning you think, well, if I'm randomly moving forward and backward, I probably won't get anywhere. But you will. The reason that you will is simply because of the fact that there's this random mistake that starts to happen, and the mistake starts to accumulate. That is also how casinos make tons of money, because people think that they figured something out, and actually they didn't. It's just part of this random wiggle. Okay, what else can we do? Let's see. Let's look at the other questions that we have here. Oh my gosh. Okay, so this is a pretty interesting question. Christopher Liu asked, why are oil prices negative? I mean, you may or may not have heard in the news that the price of oil suddenly became negative. Now, why in the world would it become negative? That's a good question. That's a good question. It's just like, what does it mean to have a negative price for something that seems like it might be useful? You may have seen in the news, like the oil prices actually went to a negative number. So you might say, that's ridiculous. I should just go and buy tons of oil right now. And indeed, that might make sense. You see, what does that mean? That price means that you have a contract. Actually, what the price was is I think it's the price of a futures contract. I believe that means that if you sign that, you need to go there and pick up that oil. So you're gonna you get paid, and actually you don't pay to get the oil. You get paid to pick up the oil. Now some of you may know that the garbage you don't get paid to give garbage to people. Do you know what I mean? It's like somehow if I have garbage and I want to throw it away, I can't be like, hey, I got some garbage. Can you pay me $10? I'll give you the garbage. The person will be like, excuse me, but I don't want your garbage. You have to pay me to take your garbage away. It's sort of that principle. So now the situation with the oil is like, maybe if you actually have a good place put in, bring over to your house and store in the basement, you might make some money, right? So the bottom line is like, if you want to sign this contract right now, you will get paid money, and in exchange you need to go and drive your truck over to go and pick up that oil, and then you'll take that oil and bring those barrels of oil and put them in your basement. There's only one problem. It's like, do you think your parents want to have 1,000 barrels of oil in your basement? I'm not entirely sure that your parents would want to put 1,000 barrels of oil in your basement. That might be a very bad house to live in, not only because it might blow up, also because it's like the smell is terrible, right? You need to actually have some way to put the oil somewhere. So my feeling is like it's probably like the price has gone down to something just because it has to be unloaded. But there's actually another reason, I think. I wouldn't be surprised if another reason why it went negative is because sometimes what's going on is people are actually, they're placing trades, they're making bets based on like what the price is. And so there might be people who are just really need to sell. They really need to get rid of their oil position. I used to actually work in New York, working on something in a place which bought and sold stocks. And so on the one hand, there's one issue called, well, if the price of oil gets really negative, surely your parents would finally agree to go and say, let's just go and fill the basement with oil and we'll make tons of money later. There's a limit to that, right? Like the price can't go too much negative. However, there is some pressure to go negative usually whenever somebody suddenly needs to get rid of this oil position. It's like people who are investing, if your parents are like investing their savings in something, oftentimes that investment goes and buys stuff. And sometimes they need to actually sell the stuff to go and turn it into money right now. That might be something to do with it, but that might be a little bit more complicated than this live stream. Okay. And somebody has said it might have poison. Has anyone ever heard of an oil spill? It's pretty bad. But I don't think that's the only reason. Actually, my gut feeling is it's a combination of the fact that most normal people are not equipped to fill their basement with oil, and you don't want to put it in the swimming pool. That's just a terrible idea. And on the other hand, I would not be surprised if there are some people who had oil positions, meaning they had money invested in oil that they had to unload very quickly. That could have been it. Okay, what else do we have here? Although, by the way, when I saw that news, I was like, that's really interesting. The fact that you could be paid something to go and pick up oil. Okay, what else can we do? Oh, wow. Okay, so I see. Stephen Mao has a question for TurtleLink. What's the cubic root of I? Now, I'm going to do this only because this live stream, I mean, I'm amazed by how much math you guys have been talking about and learning. Anyone who has been following this live stream since the beginning, we've talked about all these topics that go way beyond Algebra 1 and Geometry. And so I actually feel ready to say a little bit of something about the cubic root of I. It turns out there are 3 cubic roots. I don't have the time, I don't have the time, but I won't go into the depth of all 3, but I'll talk about one of them, which is kind of interesting, and you might be able to appreciate it in light of what we talked about last time, about the square root of I. Some of you remember that I had a way of finding the square root of a number. The cubic root of a number is similar. First I draw this, and then I think about where the I is. Actually, that vertical line doesn't look quite vertical. I'm going to do it again. Not sure this was much better, but actually I think the problem is the horizontal line's not horizontal. Let's try again. Now it's not even straight. Drawing lines is hard. Let's pretend that's horizontal and vertical, okay? So now I'm going to go and say, here's where I was. Oh, that almost sounds like a sentence. But anyway, here's where I is. The way you draw these things is that what's going on this line are the real numbers, like normal numbers like 0.2 and pi and square root of 2 and 5. Up here are the imaginary numbers. These are like I, 2i, 5i, I over 7. Now, if I want the cube root of I, remember last time what I did is I took the square root by taking the angle and dividing the angle in 2. I divided the angle in half. Well, it turns out that if I want the cube root, I should divide the angle in thirds. And you gave me I. I is convenient because I is a 90-degree angle. So the way I'll deal with this is I'll divide the angle into thirds. Thirds is 30 degrees. So now I'm going to draw 30 degrees and 30 degrees. And I'm most interested in this one. And I'm going to go out to a distance where the distance is the same as the distance that I went up, only because the distance that I went up is exactly 1. In fact, I would want to go out to a distance which is the cube root of that. And in this case, that's 1. So if I go out that far, I'll get a point that's around here. I claim that's going to be the cube root of I. And I don't know if that even looks like I don't think that looks like a 30-degree angle. I'll try again. Let's try this. Okay. And this distance that I went out is 1, and this is a 30-degree angle. Now, let's go and figure out exactly where this is. And we're going to use some, I mean, if you're not following how I did this, I didn't explain how I did this, except I said there's a pattern we saw last time, and it follows the same pattern. And what we're going to do next is we're going to find out what point this is. This is a point with some real part and some imaginary part, and then we're just going to try cubing it to see what happens. So if I'm going 1 out this far, and there's a 30-degree angle, do you know how this triangle looks? It's not just a 30-degree angle. It's actually a 30, 60, 90 triangle. This is a very nice triangle. And even if you didn't understand the I part, you can still play here. It's like if I've got a triangle which is 1 that way, and it's 30 degrees here, can anyone tell me how long is the base and how big is the height? Maybe you can figure this out. It's half of an equilateral triangle. Thank you. Epic paradox, Justin Wan. Let's see. What is this? 1 that way. Can anyone tell? Yes, thank you. I see that some people have some answers already. The height is 1/2. That's the easiest one. And it's 1/2 because this thing is part of an equilateral triangle. So this is a 30, this is a 60, this is a 90. If that's a 1, this is a 1/2. Because if I made an equilateral triangle, this would be a 1. And then that would be a 1. And over here, this is 1/2 times root 3. I will write that as root 3 over 2. Okay, now we're ready. I have a claim. My claim is that the number root 3 over 2 plus 1/2 I, which I'll write as I over 2, I claim that's a good number. Let's try to cube it and see what happens. So let's cube this number. Let's first multiply this number by itself. That's squaring it. I'll have to multiply it by itself again. I'll have to multiply it by the original number, root 3 over 2 plus I over 2 again. So let's do this once. The way we do this once, like multiplying it by itself once, is you'll get the root 3 over 2 times the root 3 over 2, which is 3/4. Then I have the root 3 over 2 times I over 2. And I have another one of them, root 3 over 2 times I over 2. Usually we write that as plus 2 of them. And it is root 3 over 2 times I over 2. Right? That's a simple way of saying both of them were the same. And the last part, I over 2 times I over 2, that's equal to minus half. No, it's not. It's minus 1/4. It's minus 1/4 because 1/2 times 1/2 is 1/4, and I times I is minus 1. So if I put all this together, what do I get? I get something. So I get the real part, 3/4 minus 1/4 is nicely just 1/2. That's 3/4 minus 1/4. And in the middle, what is this? The 2 and the over 2 cancel, and it looks like it's plus root 3 over 2i. Okay, that's good. Now I'm going to take this number and multiply it one more time by this root 3 over 2 plus I over 2. Wait, is that what I'm doing? Yeah, that's what I'm doing. Good. Let's multiply it one more time, and then that will tell me what happened when I cubed this particular number. So let's finish. I have this 1 over 2 plus root 3 over 2i times root 3 over 2 plus I over 2. Now this one I have to actually go and multiply things out. 1/2 times root 3 over 2, that's going to be root 3 over 4. Yuck. I don't like that. There's a root inside. I also have a 1/2 times minus I over 2. 1/2 times plus I over 2, which is plus I over 4. I also have this one, which is root 3 over 2i times root 3 over 2. That's equal to plus 3 over 4i. And finally, I have this root 3 over 2i times I over 2. That's 3 over 4, but the I times I makes a minus. Sorry, the root 3 over 4. And the I times I makes a minus 1. So I just have this thing times this thing is minus root 3 over 4. Oh, good! It cancelled. So if I do this, then I can cancel root 3 over 4 minus root 3 over 4. You add, and oh my gosh, it works. It works. So the answer is that this particular number cubes into the I. And it's amazing. So if you ever want to find the cube root of a number, you actually just have to look at that angle from this particular positive real line, and then just go and cut the angle in 3, put it there, and then make the length that you go along that angle equal to the cube root of the original length. And that would actually give you a cube root. And in fact, there are 2 other cube roots, but they'll be more sophisticated. I just wanted to show you this nifty thing, and that will also make it so that someday when you learn more about complex numbers in algebra class, like Algebra 2, this will be like nifty, and you will also have seen this before. Okay, what else can we do here? More questions. Oh, interesting. So Judy Andy asks, are there any math shows or tournaments that you'd recommend to us? I think that right now, I've noticed that there are actually quite a few other people who are providing math classes online. I actually don't want to recommend one or another in particular, other than just saying, I think it's great that you asked that question, because as you go, you get to see different styles. I will say I know that this style that we're giving right now is not the best for everyone in the world, and we're not trying to be the best for everyone in the world at the same time. On the other hand, maybe if you enjoy this, maybe if you're one of the people who has been coming every single time, that you might actually think it's the best for you. And so what you should be doing is you should go and check. You should check all these different things and find out what works for you. It's very hard to recommend something that works for everyone, but the one important thing is to keep checking and make sure that you know. And of course, the other piece is, if you actually like what you see today, please tell other people, because then hopefully that will help other people to come and join our community. I actually noticed that today we have 263 people, which actually seems to be more than usual. That's great. And so what we would like to do is we'd like to find anyone in the world for whom this might be what they're interested in. And if they do join us for that, then we'll have an interesting community on our own. And I hope that you will find something that you like too. Other questions? Immortal Boy says, what is the probability that a coin will land on its side, not heads or tails? Now that's a very, very unlikely probability. And the reason is because the side is not even that flat. If you use American coins, your best hope is with a nickel, because the nickel is like pretty thick and also has like that flat edge. But even then, I would say the probability is very low. If I was to guess, I would probably guess that the probability is something like 1 in... I might even go so far as to go like 1 in a million. And the reason I say that is because when you flip a coin's already got a lot of motion and a lot of wiggling around its, like these are like rotational motions. And it's very, very hard for it to suddenly drop on its side and stay there, as opposed to going on its side and wanting to continue to fall over due to momentum. You know what? I don't even think it's 1 in a million. I wouldn't be surprised if it's more like 1 in a billion. It's just actually very, very hard to flip a coin and make it so that while it's flipping, by the time it lands back on the ground, it just so happens to be like, pop, like this. Okay. Other questions? Okay. Shireen Zhang asked, why is the economy going down? Explain in a mathy way. Thanks. So honestly, I care a lot about this because that's what inspired me to start Novit, this app that we're trying to use to bring the economy back, bring everyone back to work, bring back the old normal way of life. The reason why the economy is going down is because things aren't being done. I mean, in some sense, like what is money for? Money is for exchanging things that you do for things that other people do. And if you think about all the way down, like, well, how do you have an economy? How do you have anything? It's by making stuff. But if people aren't able to make stuff because they're stuck sitting at home, well, then less stuff is being produced, less stuff is being shared. The easiest way to think of this is like, imagine we were all just like sharing all of our money and sharing all of our stuff anyway. If everyone's working, that's great. And somebody's going to be making food to eat. Somebody's going to be growing things. Somebody's going to be digging in the ground and mining. Some people will be building shelters. And there'll be stuff being made and stuff being grown. But unfortunately, if none of that is happening, then, we actually don't have money. I mean, we don't have anything that's being made. That's why you also, like, when I look at things like governments are going to bail out, governments are going to give a lot of money. Well, where does the money come from? If you think about it, money doesn't just like get printed, does it? Well, you see, actually it does. So what's really going on is that governments are able to print money if they felt like it. If the United States wanted to, it could just be like, we're going to print $10 billion tomorrow. And nothing can stop them from doing that because these are United States dollars. The United States has the right to print 10 billion more dollars. There's only one problem. It's like if you go and print like all of these dollars, then any money that you had before is worth less. So for example, imagine you were a person who had some money saved in the bank, and then suddenly the government says, we decided we want to print $1 trillion more dollars. Then those dollars you have are less rare in some sense. They're not as special, and you'll need to use more of your dollars in order to buy anything else. This is a topic that's called inflation. So the bottom line is, why is the economy going down? Unfortunately, it's just because we aren't making things. And so what we really need to do as an entire society is to find a safe way for everyone to be able to contribute again. I use the word contribute instead of work, because that's really what everyone's doing. Every single person who has a job contributes in some way to all of us having a society and a good way of life. And if we're not able to have people contributing to that, then we're sort of living on borrowed time. We're living on our savings. And that can only go so far. So we got to quickly find out what to do. Okay. What else can we do here? Oh, this is really neat. Sophia Tang says, if every person that each of us watching this live stream told, and that person told one person, and that person told one person, how many people should each of us tell to get 10,000 people here? I like this. So see, this is, you're basically asking a question that has a lot to do with like the growth of a virus, in fact. I mean, it is often called viral growth. Right now we're talking about a real virus which hurts people, but usually in normal times people talk about viral growth when you say, oh, here's something that's good. What if everyone tells someone, and then everyone tells someone, and everyone tells someone? So now the very interesting thing is what you said is, suppose everyone here told someone, and then everyone they told someone, and everyone they told someone. That's not going to make a really fast growth. That makes what's called a linear growth. A linear growth is one where you can say, well, let's see, how many people do we have right now? We have 260 something people, 265 when I just saw that. So if you have 265 people now, Then tomorrow, if everyone told one more person, then we'd have like 265 times 2. 2 times 265 tomorrow. But the important thing is that the way you phrased it is you said, if everyone tells someone, and then each of those people tells someone, it's not that it's, I want to write some more details, it's 2 times 265 people tomorrow, and of those, 265 of them are going to tell more people. And 265 of them tell more people. Okay, so there's 265 now in the very first one, and I'll say that all 265 of them tell more people. Do you see how this goes? Because then if 265 of them tell more, like tell one more person, then you're going to get 3 times 265 the next day. Next day. And of those 3 times 265, there's 265 of them that are trying to tell other people. So it's always this 265 of them tell more. And the important thing is that each of these 265s is a different group of 265. This was the first group of 265, then they kind of were done, and the next 265 went and told more, and then the next 265 told more, and it kept going. And so this is called linear growth. It's like every single day, it's going to be 265 times what day it is, basically. That's okay, but that's going to take a very long time to go and get to 10,000 people. In fact, if you want to get to 10,000 people, you roughly need like about 40 of these, I think. I think like 40 times 250 sounds to me like 10,000. By the way, the way I did that is I said 4 times 250 is 1,000. So 40 times 250 is 10,000. So you need to wait 40 days. On the other hand, there are better things to do. If what you do is not that each of them tells one more person, but if each person tells 2 people, and then they always tell 2 people, then it changes much faster. So if it's 265 of them tell not just one more, but tell 2 more, then what's going to happen here? Now, tomorrow it's not going to be 2 times 265. In fact, it's going to be 3 times 265. And the reason it's 3 times 265 is it's the original 265 plus 265 times 2, which is how many more they told. Oh, but by the way, of all of these people, those new people, each of them will tell 2 more people. And in fact, it's not 265 of them telling more. It's 265 times 2 of them telling more. Just a second. Times 2 of them. Does that make sense? Because those are the new people who came. Actually, I don't like the way the times 2 looks. I'm going to put it on the other side. I'm not sure I like the other side any better, but I'll put it here anyway. So 2 times 265 of them are going to tell more people. Okay, but not just tell more people, they tell 2 more people. Oh, wow. So in that case, how many will be here now? Well, on the third day, you have 3 times 265 plus the 2 times 265 times 2 each. You see, this amount that gets contributed is actually 4 times 265. So it used to be, just like adding 265, but now it's adding 4 times 265 to 3 times 265, which is 7 times 265. And of these 7 times 265, we have 2 times 265 times 2 are new people. And so there are 4 times this many people telling each 2 more people. Does anyone see what's happening? This is actually quite interesting. Rong Hong Lin says, I wish this could happen. I also wish this could happen. This would be awesome. So if everyone who looks at something says, oh my gosh, I actually like this, and then they tell 2 other people, you get what's called exponential growth. This is very different from linear growth. What we saw earlier was like 265, 2 times 265, 3 times 265, 4 times 265. But no, this is different. It goes 1 times 265, 3 times 265, 7 times 265. Actually, you can already see where this is going. What's the next number if I want to follow a pattern? 1, 3, 7. What's next? Well, you see, these all have to do with powers of 2, right? Like the deal is that I'm doubling. There's a lot of doubling going on. And if you think of powers of 2 are like 1, 2, 4, and 8. And so 1, 2, 4, 8, what those have to do with this is 1, 3, 7. I see a lot of 15s. These numbers are all 1 less than a power of 2. If I kept going, then it would go to 15 times 265. Remember I said I need to get to approximately 40 times 265. 30 times 265. No, not 30. 31. 1 less than a power of 2. 31 times 265. That's already almost, is that almost 10,000? No, it's not. Let's keep going. And the next one would be 63 times 265. You wouldn't even have to wait anything close to the 40 days. It's like day 1, day 2, day 3, day 4, day 5, day 6, less than 1 week. Poof! And that's actually the power of exponential growth. So I do hope, I mean, if you like what you see, do tell people. It'll be a lot of fun. This is actually what we need to do, because if this is something that the world wants to have, this kind of an interactive math stream where we talk about all kinds of math, we need to have people who want to watch it, because then that makes it worth doing. Okay. And I can tell from the fact that we have more people today that people must have heard about this recently from some other source. And so I want to welcome all of you here if this is your first time. The way that we do all of these live streams is that we just go and see what kind of questions came up. And I'm always going to try to go and use topics that maybe can be understandable to as wide an audience as possible. What else can we do? Well, we got a few more minutes. Let's see what we have here. Oh, wow. Shireen Chang, you asked, what is the probability of 2 people told the same person? So now the deal is that the world is a fairly small place, in the sense that a lot of times you say, well, there's 8 billion people in the world, but oftentimes it's like if you told your friend and you told this other friend and then they told friends, it's like you suddenly found out that everyone found out too soon. And that would be because your networks that you're in are often quite tight, in the sense that people who are your friends are friends with each other. So the answer is, in fact, quite possibly many people would have a situation where they told people that they already told. So in that case, it wouldn't actually grow this fast. If you want to model that, you would actually effectively reduce this number called 2. Actually, what we're talking about now is directly related to the spread of virus. That's actually what this is all about. And as more of the people already know, you won't be multiplying by 2 every time. You won't be always having tell 2 more. It'll become something like every person on average tells 1.5 more. Every person on average tells 1.2 more. And then the moment it becomes every person on average tells like 0.9 more, then it starts to peter out. Oh, peter out for you guys is this way, peter out. Yeah, so that's a very good question. But my hope is that if you somehow have friends which are distributed, like far enough away, tell your friends. We like to have a community that spans the United States and the globe. I see. What else can we have? Oh, I love it. The person called Hello said, okay, people, my name is. There are all these like great name tags that say, hello, my name is. And that's just what that made me think of. Okay, what else do we have here? Oh, wow. Okay, Dayan Hassan asks, if the IMO questions are getting harder gradually throughout the years, do you think the value/weight of an older IMO medal is less? Well, this is a deep question. I mean, the questions on the IMO are indeed getting harder, but at the same time, a long time ago, it was harder to get a medal. The reason is because at the International Math Olympiad, only half of the people get medals. And if you want like a gold medal, only like 1/12 of the people get gold medals. And so because of that, if you have less people participating in the contest in the first place, 1/12 is even less chance. So in fact, some people say that the old gold medals earned in the 60s and 70s, when there were only a few countries, those are worth a lot, because those were really, really hard to get. Only a few people got them. You'd have to be like one of the top, 5 or 10 people in the entire world. More questions. What do we have here? That's a neat question. Where are you filming the stream from because of COVID-19? You're right. I mean, we don't really have an easy way to go to a studio, but it just so happens that I actually have been running an entire online class called the Daily Challenge with Po-Shen Loh. So we actually have our own studio. In fact, in this studio, there's no one else. I'm the only person in this entire building. So well, in this entire floor, we have a second floor of a building. So I am social distancing. In fact, I'm probably closer to all of you right now than to any other human being, well, at least in conversation. But at the same time, we happen to already have this studio that we can use to run all of these classes. And so when we had COVID-19 strike, I decided, let's just go and use the studio that we already have. The Daily Challenge online courses, yes, those exist, but I just wanted to do a contribution to anyone else in the world who just wants to have some kind of an interactive chat that ranges all over math. So this is not a course. I mean, right now, this is not a course. This is just like, let's talk about math and have fun. And because we already had a studio that could do this, we just used it. And maybe I'll make a comment then. In fact, there's going to be another show in this studio that I'm going to run in approximately half an hour. If you're curious at all, you're welcome to join. But that particular show is directed towards math teachers. So every single year, every single spring, I usually go to New York City to an organization called Math for America, which works with some amazing and very dedicated mathematics teachers from New York City and New York State. I can't go right now because, unfortunately, a lot of the United States is not really traveling. But what I'm doing is I'm using the same studio to broadcast to them on the topic of matrices. So again, that's not the topic that we were touching on here. We were doing things that are more a little bit more basic in math. But if there's anyone who's interested in talking about matrices, in fact, that's what's going to happen in about half an hour. So the answer to your question of like, where am I broadcasting from? Well, this is the studios of Daily Challenge with Po-Shen Loh, and we're trying to make the most of it that we can. Okay. And, oh, well, with that, I think I'll say, let's try to find a soft question to go and oh, you're nice. So, and finally, I can try to read your name. It's hard. It's like P14Y3R0N3. Do you feel lonely? To be perfectly honest, no. And that's because I'm talking to all of you. So I actually think that what we need to do in this time of social distancing is find a way to at least socialize with other people and stay human. And to me, every single day, to be able to turn on this camera and to see, okay, there's going to be all these people, I actually recognize a lot of your names already, to be able to talk to some interesting people about math, now I don't feel lonely. So thanks for making me not feel lonely. I hope that you also don't feel lonely. And I'll say we'll have to sign off for tonight because I need to get ready for the math teacher's live stream in half an hour. So have a good day, everyone. Everybody stay safe. Everybody stay healthy. And I'll see you tomorrow. See you.